Okay, this is problem 1-1, and all I'm going to do in this video is talk about how to find your reactions at B, C, and then what your resultant internal loadings would be at E. Alright, the first thing you want to do with a problem like this is draw a free body diagram. Again, it's not so important to get everything in the right direction. Just make an estimate about what direction you think it's going to go. You have no horizontal, so you can ignore the horizontal. Now at this point, what you want to do is you want to find out what the reaction is at C or B. I'm going to find out what the action is going to be at C. By doing so, I'm going to take a moment right here at this point here. So now I'm going to say the summation of moments at B must equal to 0. I'm going to let anything that goes this way be negative, anything that goes this way be positive. So we'll start with the 400 first. It's going to be 400 times this moment arm. Moment arm has to be at right angle. So that would give me 1600, and it's going back this way, so I'll make it positive. Plus, I got F of C times the distance, which will be 8. Again, if I show it positive here, then it's going to go back this way, so I make it positive. Minus 800 times this moment arm, which is going to be 4, 8, be 12. We set that equal to 0. I'll get the calculator out here. I'm going to get 1600 minus 800 times 12. And I'm going to recommend that you do it this way here. FC times 8 minus 8,000 is equal to 0. Move the 8,000 over. 8,000 is equal to FC times 8. Divide by 8, FC in this case is going to equal to 1,000. Now the reason I'm saying do it this way, because if I get FC as positive, then it means I've identified this the right direction. If I get negative, then it would have to come back down. So I know right now that this has to be 1,000. Okay, at this point, all you have to do is sum your forces in the y direction, set that equal to 0. You got minus 400 coming down. You got FBY going up. Plus 1,000 going up, which is the loading at C. Minus 800 coming down. Again, equal to 0. And I go ahead and just summation all this. That's minus 400, that's minus 1,200. That gives me FBY minus 200 is equal to 0. Move it back over, and I get FBY is equal to 200. Again, since I have this as positive, and identified my free body diagram as going positive, then I've done it correctly. So I make this into 200. Now, if you want to identify what the loading condition is going to be at E, all you're going to do basically is you're going to cut the beam in two at this point right here. And you're either going to look left or look right. It makes no difference whatsoever. I'm going to look left. So what I'm going to do is I draw the beam. And actually, I'll tell you what I'm going to do. I'm going to see if I can snap a picture of this. Might make it easier. I'm going to snap a picture right here. Go back to my model. Scroll down here. Place it right here. Okay, and that's what the beam is going to look like. So now I'm going to draw what my reaction I think is going to be. I got 400 coming down, so I got 200 going up this way. So I can say that I think the VE is going to be pointing up this direction here. Okay, so all I have to do now, and again, you can do the moment same way, and you can say, well, I think the moment's going to go back this direction here. like that. So now all you have to do is sum the forces in the y direction. I will get minus 400 going down. I'll get 200 going this way, plus F. What was that letter? Sorry, I can't read the letter. Move this out of the way. That's E, sorry, E. Plus FE is equal to 0. All you have to do now is solve for that. And what you'll find out is FE must be going up 400. That gives me, that's going to give me a value of 200 there. So what that really means is I got shear going across there. So if I look on each side of E, what happens, I have shear that's going like this and like this. It's just shearing across that face there. Okay, now to find the moment at E. To sum the moment at E, I set that equal to, again, equal to 0. Come here. Okay, and when I do that, all I have to do is to sum the moments. I'll have 400 here times this moment arm, which is 8. Okay, and I got plus 200 times 4. And again, I'm going to make this one negative because it's going back clockwise. Plus the moment at E. Is equal to 0. And when I do that, I get 400. That gives me 3,200. Minus 800 here. Plus ME is equal to 0. And I'll find that ME must equal to 2,400 kips pound. Or, sorry, kip feet. Okay, and that's all you're going to be doing with these type of problems here. And you noticed when they did this problem on the solution, they basically got the same values as they got the same values I got. The signs aren't that critical. You just need to draw the arrow the way the moment would have to go. So your two forces would be this and would be this, and we'd need to put units onto this, and that's 200, and that would be pounds there.